Hey, John. All right, we'll get started in a couple minutes for those of you online. All right, let's get started. Yeah, so our speaker Blake is running a couple minutes late. He'll be here in like 2 minutes, but he wanted me to play this incredible video in the meantime. Hold on, or let me share my screen again.
All right, good. You guys know what WAT?
Hold on, can you guys online hear that? Can you guys hear that on Zoom? Yes, okay.
That means
Yeah.
WAT. Exactly. Let's talk about Ruby. In Ruby, if you reference an undefined variable, of course it name errors, as you would expect. And if you try to assign B to A with them undefined, of course it name errors, as you would expect. And what happens if you try to assign A to A with A undefined? Correct. Nil. Let's talk about Ruby. In fact, it will even support bare words with bangs in them. And this is not deserving of WAP. This is actually a result of how awesome Ruby is. But if you ever actually do this, then WAT. Let's talk about JavaScript. Does anyone know in JavaScript what array plus array is? Well, let me ask you this first. What should array plus array be? Empty array, I would also accept type error. That is not what array plus array is. Wrong. Wrong. Array plus array is empty string. Obviously, I think that's obvious to everyone. Now, what would array plus object be? This should obviously be type error because those are completely disparate types. Does anyone know what this is? No. Close. No. Far away. It's object. Right. Nicely done. Now, of course, because this is plus, so you can flip the operands and the same thing comes out. So if we do, what? No, that's just an object. If you do object plus array, you should get exactly the same thing, which, as you can see, you do. And finally, the only one of these that's actually true is, because you add arrays to get empty string, that doesn't make sense. But an object plus an object is actually not a number, technically. So this one's actually right. And exactly, right? Like, what is even going on in this lab? I don't even understand what person with a brain in their head would think that any of this is a good idea. Okay, enough making fun of languages that suck. Let's talk about JavaScript. If I say array.new 16, or just array 16, I get an array of 16 things, which it represents as 16 commas, which is obvious. And if I then join those with a string, then I get the string 16 times. This is actually the only line in this entire presentation that's reasonable. Now, if I take that string and then add a 1 to it, it interprets the 1 as, or casts the 1 to a string, and then we get WAP 1 a bunch of times, fine. Does anyone know what will happen if I subtract 1 from the string? I'm assuming no one does. I'll give you a hint. Does this help? Does anyone know? Wet man. That's all I got. Thank you, guys.
All right.
All right, unmuted.
Okay. Our speaker, Blake, is now here, so that was just a temporary distraction. But yeah, so that's not related. So our speaker, so if you're not familiar with Blake, Blake has done a lot of research into programming languages. He has his degree on language robots, and he's obviously the founder of SSD, and this will likely be the last presentation that Blake will give for SSD. So it's kind of a special occasion. Everyone, please welcome Blake Anderson.
All right, try to share some slides here, and let me make sure the Zoom screen share is working fine. Oh, I hate that bar. Where's the way? Okay. Screen. There we go. Perfect. All right. Can someone on Zoom confirm that things are audible, visible? Confirm that things are audible. Thanks. That's not echoing, right? That was just you unmuted, right? Okay. All right. Cool. Eric, if you want to keep an eye on Zoom for any questions, that would be good. Let's get into it. So we're going to talk a bit about programming language today. This is a bit of a revisit of a talk that I gave a couple of years ago on 4 key things to know about programming languages. This is meant to kind of get you interested in the area, kind of show you why it's worth it to take a closer look at programming languages, try to study them from a little bit more of a fundamental level rather than just learning to write code in said language. The other aspect here is that at the end, I'll spend maybe 10, 15 minutes or so taking a look at some different things in my language, Roblox, and I'll hope the examples don't break on me. So, that said, let's get into this. About me, as Eric said, of SSDs, so I've been here for a while, and this will indeed probably be the last talk. Roblox is the programming language I've been building for about 4 years now. It's also been the subject of my honors thesis and my master's thesis, so I've written 2 papers on the subject. We'll take a look at some of the DSL stuff there later. I also founded a startup called @Local, which is discovery for local businesses. So I've done 2 internships and part-time work at Infotech. And then finally, I'm a contributor to Sponge, which is a Minecraft modding API. So I've been doing that for about 5 years. Okay, so why bother? So why should we talk about programming languages in the first place? There are a few reasons why you might be interested in programming languages. One is just to learn about new languages, and the other is to kind of create your own. So if you're actually doing a deep dive into programming languages, what you're going to find is that languages take inspiration from other languages that already exist, right? Pretty much everything is built up on that kind of iterative feedback loop, right? Java is very similar to C++, and then Kotlin is very similar to Java, and it kind of just keeps going on and on. So if you understand kind of the fundamentals of programming languages, then you're able to work with a wider variety of languages and understand how are they similar, and sometimes most importantly, what are the small nuanced differences between them that are critical for me to know to understand, right? So for example, JavaScript and TypeScript. If you understand some of the behaviors of JavaScript, it'll make TypeScript a little bit easier, right? Part because they're almost the same language, but also because TypeScript relies on the JavaScript runtime. So if you understand some of the things there, then you're able to make use of that more. Second is if you want to create new languages. So why might you want to create a new language? Well, one is just to kind of understand more about them, but that's a little bit recursive, no pun intended. The second is there are many reasons why you might want to create a new language. Sometimes they're general purpose things because you learn more about computer science as the field grows and evolves. So for instance, Rust, right? Has everyone heard of Rust? Has anyone not heard of Rust? Okay, so Rust is a pretty well-known systems programming languages that adds a bunch of memory management features. And so what Rust did is it developed this system for tracking ownership, so who controls memory, and it basically added this as a layer on top of C++, among many other things, that solves a whole bunch of memory management problems that would occur in C or C++ when working with pointers and other things like that. And so this is kind of new development. And so you build these languages with these new features because they're more safe and they're more reliable. So as software kind of grows and grows in complexity, those types of systems are much more valuable. A second reason is that you might have something like embedded DSLs. So DSL is domain-specific language. So we've all probably worked with SQL. We've all probably at least seen regex. And we all know of HTML, of course. All three of those are domain-specific languages. And you might need to build your own, whether it's something like a special configuration format or in a more, kind of large-scale environment. You might be building a DSL for scientific research or something like that, right? Think some of the different Python libraries for SAT solvers or other different things like that. And so you might be in environments where you're doing things like that. Yeah.
So why did you create Roblox?
So why did I create Roblox? This is a great question. Because I'm an idiot, that I didn't know what I was getting into. Not that I would change it now. We'll talk a little bit more about robots later with things. So the main reason was I didn't know what I was getting myself into at the time. And the main reason now is because I think I found some cool things and I want to see it through. So, okay, so here's some languages, right? We're all kind of familiar with these languages. These are kind of your standard languages. There's a few standard ones missing. We'll probably see them on the next slide. But all these languages are pretty old, right? I mean, all these languages are 20 years old now, right? Python is 30 years old now. So 32, technically. So who expected that? So Python's pretty freaking old. So, and let's not even talk about C. So here are some other modern languages, right? So some of these are kind of cool, right? Swift is an interesting one because Swift completely took over iOS development because Apple said use Swift and no one else really had much of a choice. But there's other ones. Rust is here, Go is here. Elixir is a cool language, Elm is nice. Zig is another really interesting one. Zig is actually one of kind of the first independent small scale languages to really kind of make it big. The developer of that, Andrew Kelly, does really amazing work with Zig. So there's a lot of different themes, resources, all kinds of things going on there. So it's a really cool project from my perspective because it's a good role model for me with what I want to do. Okay, so parts of a language. So a language is not just a compiler. That's a large part of it, but it's really not. So first off, you have the language itself. So this is like your design and your implementation, right? So you figure out what the language is supposed to do. You design a specification. And this is the thing okay, we have an if statement in the language, and if there's a Boolean thing, and if it's true, evaluate this, yada, yada. And then your implementation is your things like the compiler or an interpreter or whatever else you're doing to evaluate all that. And that's kind of the core of the language. But for it to be usable, you need a couple other things as well. So one thing that you need is a standard library, right? If you don't have a standard library, you can't really do a lot with the language, right? This is kind of one of the large problems with Roblox right now, to be honest, right? I don't have anything that allows things like file I/O operations or really even many other basic functions. And so as a result, there's not a lot you can do with the language unless you want to do it very, very, very manually. Not that Roblox can do that either, so no point. Another thing is tooling. So this is things like your build systems or other things like that, right? So think like make files in C, but not terrible, right? So this could be other things like testing systems, right? You want to be able to write tests for your code to evaluate that. And so pretty much every language has some type of test framework, right? Jest for JavaScript is a very common one most people have heard of. And then JUnit for Java is the one I'm most familiar with. And then finally, the community aspect of things, right? You need to have a number of people who are actually using your language, which kind of depends on the other two. And they're the ones who are going to be able to support other people trying to use your language as well. That way more people can join. And then that's going to cause growth because they're going to, they're going to be supporting other people. Those people will come in, they'll build new libraries or other systems. So, and then you'll just kind of keep snowballing from there, hopefully. In practice, it's a little bit harder than that. And so this can include all kinds of different things. Many languages now have like Discord servers, other stuff like that. So if you have questions about things like Java or whatever, the Rust one, for instance, is official, right? There's an official Rust Discord server. So like the Rust developers in there and all kinds of other community members and people on the Rust org team and other stuff like that. So it's pretty cool. Okay, so there's a few different ways we can classify languages and other things like that. This is just kind of a list. I'm not even really going to read too many of these. I'm going to hit the kind of the main ones. So imperative and declarative, that's one you've kind of heard thrown around. This really doesn't mean anything. You can Google the terms if you want. Static and dynamic type, we'll talk about types later. Object-oriented, procedural, functional, logical, actor model, right? These are paradigms, right? These are all of our different language paradigms that we hear of, right? And so, one, languages don't have to be a single paradigm, so there is that. And then you have other things like whether it's designed for systems. Systems generally means low-level memory management stuff, or other things that depends more on the architecture you're building toward. And then scripting is, write it once, done, gay Python. Okay, so here's some more interesting things. So even languages that share the same paradigm can differ in interesting ways, right? So for instance, JavaScript is technically object-oriented, but it uses a different model of inheritance than we see in C++ and Java, which are pretty similar. And that's prototypical inheritance. Prototypal? Something like that. Anyways, it uses prototypes in order to manage inheritance. There's other differences, things like error handling. Some languages have exceptions. Some languages have other methods. And then, some of the other ones from here too. I have design patterns in here as an interesting note because depending on the features a language offers, you may or may not have design patterns that even make sense in that language, right? So think about it, design patterns are basically, designed to get around and solve usable problems depending on, how you have to build your system. But languages that are powerful enough may be able to just kind of natively support that. So an interesting example of this is like properties in kind of more modern languages. So modern languages can do things like properties where you can basically say, hey, I add this new property onto something and it can just kind of delegate or do other kinds of crazy things. So there's kind of a lot of more syntax sugar for doing some of the things like that and kind of make some of the design patterns obsolete. So that can be an interesting thing to look at if you're interested. Okay, the compiler. So the compiler is not magic. It's actually pretty straightforward. So we're going to take a brief kind of like walkthrough of what the compiler actually looks like and the core different parts of it. The point is not where you're going to be able to build all of these, but at least that you'll understand kind of the key things that it's trying to do and kind of how that's subdivided amongst itself. If you've taken PLC, you've seen all of this stuff before. It's pretty much the same. I have a footnote here about compiled versus interpreted languages. And so when you have a compiled language, basically all you're doing is you're taking a compiler and you're turning it into another language, right? So that other language could be something like C, for instance, right? There are many languages that compile to C because C is a good universal system that can, it can be compiled onto anything. It can run very fast, so it's a good language to try to target. And so this other language is another source, right? So it just kind of loops back around. Now you can also compile directly to machine code. This is a little bit rarer. Normally you have something like assembly and then the assembly does things and sometimes that even happens on the machine itself at that time. One of the main reasons why is portability. So you want to make sure that you can build a thing and then run it on a large number of different systems. You can build it specific to each system, but then you have, hundreds of possible executables that could be run depending on the computer, and so it becomes a lot harder to work with. And then, of course, finally, it actually does the thing. Now, if you have an interpreter, right, the kind of model of an interpreter is that it basically just interprets the thing and it just does what it is automatically. But that's not necessarily the case. So what actually happens is that in most interpreted things, you're really just using a compiler that compiles down to another language, which in this case is a specific bytecode. And then that bytecode is run by some type of virtual machine, right? There are languages that just kind of run the AST directly. They're rare. They pretty much don't really exist for any sort of practical thing. So in reality, your interpreter is basically going to just compiled down to bytecode or even sometimes machine code. And so this is things like JIT compilation, just in time. This is what Java does. And it's also what most versions of JavaScript extensions do. So V8 for Chrome does a lot of different things like this. And so the diagram here is a bit complex, but a few things. The main thing is that your compiler is basically one of two things. It's wrapping over to another language to some source, and then eventually that's going to be interpreted and turned into machine code or whatever else. Or it's going to bytecode, which is basically just another language anyway that's eventually run by a virtual machine, and your virtual machine is the interpreter. So, and then you just have machine code thing, right? So if you notice, the colors for these arrows are basically identical, right? It doesn't really matter which one it is, right? The compiler goes to another language or bytecode. That eventually goes over to an interpreter or virtual machine that's run for things, and that goes to machine code, or eventually just does the thing, right? So this is kind of the key idea, which is that so many people talk about compiled versus interpreted languages, and it's really not a major distinction or really any distinction. So for instance, Python is the last example here. Python is not really an interpreted language. What actually happens most of the time when you run Python scripts is it'll actually compile that to something like C, and then CPython, and there's also things like IronPython, which are even more ridiculous. But it'll have basically these virtual machines that'll run those types of compiled things and just roll with that. Okay, so here's a quick overview. Let's skim through this pretty quickly. So we have 5 kind of main steps. We have a lexer and a parser. These two kind of work together to basically process the input. We have an analyzer. So the analyzer's job is to do all the kind of different validation things. So this is things like type checking. And then finally, a compiler or an interpreter. And so the compiler is going to mainly go to another language. The interpreter is mainly going to be trying to run things. Just depends on what you're trying to do, but different sides of the same coin pretty much. Okay, so the job of the lexer is basically to take some string input and break this up into little bitty pieces that can be easily worked with. And these are called tokens, right? So these are things like names of identifiers or entire numbers. We don't have like a 2-digit number here, but we want to work with a number as multiple digits, not just 1 digit at a time. It would be way too painful to do otherwise. And so the lexer is kind of an intermediate part of the parser that does this. And so, for example, you can see a string literal here, right, where we get this entire string literal as one piece rather than many separate pieces. And that just makes, it easier to work with later. So the next kind of piece here is that you have a parser. And so this takes all of those tokens that the lexer figured out and turns this into what's called an abstract syntax tree. And it's kind of like a hierarchical representation of things. So we can see we have this source. So this is some source input, and we have print. Then we have the parentheses of the function, which doesn't actually matter as far as how it goes, right? So the AST just says you have some number of arguments, and here's the ASTs for those arguments. So the parentheses are pretty much dropped. The other thing that you'll notice here too is that the abstract syntax tree actually encodes things like precedence, right? So you'll notice that the star part for multiplication actually occurs lower than the plus does, even though the plus came before, right? And this is because multiplication has higher precedence than addition. And so the end result is that you have 2 times 3, and that small chunk of the AST gets evaluated first, and then the result of that is concatenated with the string, right? And so then the analyzer, and so this kind of does something like this. It turns the AST into what's called an intermediate representation, or IR. And so these things are now differently colored because we've kind of gained type information and other kind of things like that, which would be virtually impossible to actually show here. But for instance, we know that print is a function. We know where the function's defined. We know what it returns. And then for plus, because we have a string operand on the left-hand side, we know that we're concatenating. And so we have some function that describes how string concatenation works, what types it is, what it returns, and other things like that. And so we collect all of that information in order to validate the program and store this in this intermediate representation. We can also have later phases that do things like optimization, but that's a little less important. And then finally, missing an animation there. But finally, we have a compiler and interpreter. And so the IR either goes to compiler, where it gets turned into something like, in this case, there's some example assembly there, or another language, in this case C, Sometimes they're called transpilers, just to kind of clarify that it's going more toward like another high-level language rather than like machine code or other things like that. And then lastly, you have the interpreter here, which actually evaluates this. And so this case, it would print, 2 times 3 equals 6 because it's concatenated and then printed out. Okay, cool. And whoa, I think this is a video. Yeah, here's parsing. Here's a demonstration. We never have sound on these things. Feels bad. I don't know how I get sound. Okay, anyways, just imagine. Okay, just imagine it was playing that for the rest of the video too. I don't know what happened. I don't think I hit anything. Anyways, okay, so we're kind of on to some of the more theoretical stuff. See this pretty quickly. So one of these is type systems. Let's talk about what is a type. So a type is basically some type of formalized description of what some type of data means, and what operations can be used on it, right? So for example, hello world, this is string. So then we have integers and then just kind of some arbitrary other types things here. Down at the bottom, we have a function, right? So this is a function that takes 2 arguments and then adds them together. And so you can kind of represent this in different ways, but one way is basically saying that it takes 2 arguments of the same type, adds them together, and produces something of the same type. This is one way to represent it, but not the only one. Yeah?
What is that X colon A?
So X is of type A. Yep. So the colon is commonly used in most modern languages to represent types. That's just kind of the syntax that seems to have been settled on.
So is A like an arbitrary type, or is it just literally A type?
Pick your poison, right? So all of these are basically arbitrary types in extent. So it's just whatever type A is. So same thing with T. So generally like 1-letter capitals are kind of like more for generics. So that's kind of the idea there to an extent, but yeah, it doesn't matter. And then finally, so we have a type system. And so a type system is basically you take a whole bunch of types and combine them together. And so this is kind of what that looks like. So in Java, for instance, you have the object class, right? This is the super type of pretty much everything. And so then you might have a number, and then these numbers have integers and doubles, right? And so this is kind of the hierarchy that you get from this. But then you can have kind of other things which make the hierarchy a little bit more complex. So for example, we can have string, which is also a subtype of object, but it's not a subtype of number. So it looks more like this. And then you can add more things like comparable. And very quickly, you can see how this gets very spiderwebby. However, the core idea is that it's always going kind of from the top down, right? You're never going to have any type of circular things going on. And that's kind of really important when it comes to actually being able to think and reason about how types work. If you had circular inheritance, I don't even know what would happen in that case. Yeah.
So exactly like the languages themselves, like this is kind of information access to what makes it how to construct it.
Yeah, so all of this information can be stored. So for instance, in Java, you have class objects, right? And those class objects store almost everything that you could possibly want. You can use reflection in Java, which is runtime modifications of the code basically to access methods by their name, to call them. You can do crazy things like even change the value of constants or fields or other things like that through that. A very fun, stupid thing that you can do is Java has a cache of integer objects. That way it doesn't create like 40 objects all representing the integer 1. You can just kind of like access that cache, which is an array, and then just like run a shuffle algorithm over it and just randomize all of the numbers. So I give it about 3 seconds before the program crashes at that point. So, but it's super fun to do. Yeah.
So how do primitive types fit into this?
That is a great question. The short answer is in most languages they don't. Primitive types pretty much exist separately. Java does this boxing operation. So integers, or more accurately, ints are boxed into the class integer, right? And so, but that's a manual process that the compiler does automatically for you. The manual versus automatic makes sense, right? It doesn't, like at machine level, they're different. The compiler is smart enough to do that for you when it needs to. However, most modern languages don't have primitives anymore. So things are just kind of fast enough where they work well enough without it. And a lot of the times nowadays, you're kind of doing more sophisticated things with numbers and less like this. Low-level system languages will still kind of have primitives, but that's about it for the most part. A good example of this is like in Java, right? How many bytes is an int? Okay. How many bytes is an int in C or C++? Yeah, that's the right answer. It depends. It depends on the machine and the architecture and other things. We generally think that it's 32, but it can basically be anything. And there are even some architectures where it's not even a power of 2, right? There's other things in play too when you're dealing with that, where you have basically different representations. So you can have like integer or an unsigned integer, right? But you could also have things like 1's complement versus 2's complement or other types of things going on. So for those of you who remember computer organizations, they're generally avoided in modern languages because you just build different types to express those things. And it makes more sense to do that using the normal type system and have it fit into everything else than to have 50 bajillion primitives. So that's kind of why. And so then finally we have types of type systems because, yeah, meta. And so we've all kind of heard strong versus weak type systems. Basically, weak is that it does some conversion things. This is the type of stuff that you saw in the Watt video, right? So that type of weak type systems and conversion is what results in JavaScript and sometimes Ruby. And then finally, you have static versus dynamic. So static is more like you have a compiler that's validating things. Dynamic is validating during runtime. As before, we saw Python. You can compile Python stuff without really knowing the types and just kind of have an interpreter process that and do all the type stuff that needs to at runtime. Python is an example of a strong dynamic language, right? If you give the wrong type of thing in Python, then it'll throw an error. So that's another difference between Python and JavaScript there. In general, you can mix and match these however you want, really. But in general, you're mostly working with strong languages that are either statically or dynamically typed. So here's kind of a graph kind of showing this. This is a bit of an old graph, so here's some kind of handwritten ones that I added in myself. You can see most languages are kind of going towards strong typing nowadays. That's pretty much settled. Static typing is winning, but there are still dynamic languages out there, and there are relatively reasonable reasons for those. That is a mouthful to say. And then finally, some notable types. So for example, functions. So things like some parameter x, some parameter y, and this returns a z. And so this is used by Kotlin. So this is where I had the particular example from. But basically, all languages now have some type of generalized function type. That way you can represent and kind of store code and pass it around. So nullable. So languages that represent null certain ways can do this a variety of different things. Java, for instance, just lets everything be null. That's dangerous. That's a bad thing to do. And pretty much no modern language since has ever done that. So that was literally the billion-dollar mistake. So optional is another way for it, where you kind of wrap it to identify everything. Yeah.
I'm not too familiar with why like having anything be null is dangerous. Can you explain that to me?
So if you have an object in Java, it can be null, always, right? You have to explicitly check every single time that it's not null, right? Think of it like C++ pointers, right? So if you dereference a pointer that happens to be null, you're going to get an error. Well, in Java, everything is a pointer, basically, right? So it's not that there's no such thing as pointers, it's just that everything is a pointer, and so there's not really anything else besides primitives. And so the catch-22 of that is Java basically made it so that everything could be null. But the only way you can really be like fully type safe on that is to explicitly check every single parameter of pretty much every function, whether it's going to be null or not. The compiler is not going to validate that for you.
I'm confused. I mean, when I use Java, whenever I try to use null, it gets throws a null pointer exception. So how is that not safe?
Well, it will, but it'll throw it at runtime, not at compile time. So like Java's entire static type system is fully broken by the use of null, right? Because static type is if I know that something is of type let's say string, and I call string.replace, then it replaces the string and it works. But that isn't true if the variable that has type string is null. Because even though it has type string, its value is string or null. And so if it's null, it won't do replace, it'll throw something else. So like, I mean, you can describe it as, yes, that's the core semantics, but really it's not what the intended or expected behavior is. And so as a result, you have to check for null everywhere. So,
Okay.
so yeah. Result types, this is another thing for error handling. More functional languages use this. Mutability. So this is actually something kind of interesting. So the idea to express whether a value is immutable or not. So if it's mutable, then obviously the data can change, and so there's certain things you can or can't do with it. For example, caching is a huge thing. If you have mutable data in a cache, that can be really bad and really dangerous. Another thing that's a common mistake people do is they have like a mutable thing inside of a map, right, as the key. So you have some data structure that's mutable, you put that in a map, the key changes, and so now the hash codes of those are different, and you're never going to be able to find the thing again. And then also ownership. This is also a Rust type of thing, and this is for who owns certain memory, because the person who owns memory is then responsible for deleting it. And so this is how you avoid the case of, well, I just have random pointers everywhere. I have no idea who created them, and I don't know if they're reserved or if they're free or what. Okay. And then lastly, there's like math and stuff behind types. So this is type theory, because I don't know why people need this. So I'm sad to say I actually know what this means. Yeah, it's only type theory, just like rocket science. What's the big deal? Okay. All right. The last main concept that we're going to talk about here is metaprogramming. And so this is kind of the idea that code is data and data is code, right? And so fundamentally what this means is that you can store code in a program, send it around, store it in variables, and run that code, right? And if you get sophisticated now about it, you can go back and forth between code and data. And so you basically just transvert one to the other. And so that allows you to do a lot of really crazy, powerful things that are very cool, but also very dangerous. This is kind of popularized by the Lisp programming language. So Lisp was kind of one of the major kind of things that really kind of got into this direction of these macro type systems. And so we're going to talk about that. So for instance, so here we have our kind of previous print example, right? And so in this case, right, what we have is we have a transformation that basically says, okay, we have 2 times 3. These are both constants. We can turn that into the number 6, right? Because it's also a constant. Ever, right? It's not like multiplying variables together or multiplying constants. I didn't point it out, but this was another thing that the analyzer did previously. It can do those types of optimizations and other things. So macros are basically functions that take in syntax and produce syntax. Syntax here being code, basically. And here's an example, right? You can basically say that, hey, there's a whole bunch of operators and they do like crazy things. And so if we have some plus with a number of arguments, then we basically train that to the function add. Right? And so this allows us to basically replace a whole bunch of operators with some function that's named add or whatever else. And we can get this arbitrary complex or arbitrary complicated with things. This is just kind of a general example to kind of demonstrate the idea. Right? You have some type of binary operation go in, and you have a function call with a normal sounding name come out. Yeah.
So I know C++ that allows you basically like define your own operators in some ways to count as a macro.
Even C has macros. Yeah, great segue. Yeah, so you can do things like this. This is just ridiculous, right? Like just look at this for a second, right? So basically what they're doing here is they're defining so many words as being arbitrary stuff that you can write a sentence, right? I guess this is a paragraph. So we could write a paragraph, we'll be technical about it, that does normal program stuff, but is completely undecipherable. There's something called literate programming, which is like this, but not at all like this. Don't confuse this nonsense with literate programming. But anyways, you can do things like this, but there are some dangers here, right? So let's take a look at this example. And so we have some square root macro, right? We call square root of x plus 2. And then what? What's happening here, right? Okay, so let's take a closer look at what's happening here. So we have square root of x plus 2, right? So, oh, yeah, x plus 2 times x plus 2, priority is x plus 2 times x plus 2, right? Because operator precedence. And so the key idea here is that these are not sophisticated representations of anything at all in C, right? C macros are purely text-based, right? They run as part of the preprocessor, and as a result, you can have them do very, very, very dumb things like this if you're not careful. You need to know exactly what you're doing with C macros and how this works, which is a reason to study programming languages, because if you know this is what it does, you'll never make this mistake, right? Or, I mean, you will, and then you'll hit yourself for it, and then you won't make this mistake for another couple months. And you'll be able to identify what's exactly going on in these types of cases, right? This is one of the reasons why macros can be pretty dangerous, depending on the language you're working in, right? This idea is pretty important, right? So is anyone confused on this? Because it's going to get a little bit worse on the next slide. Okay, and by worse, I mean better. We also have kind of flow here. Okay, so macros in general operate on syntax, not text, right? C macros are an exception because they're done by the preprocessor. But macros in modern languages, like for example Rust, operate on the syntax. And so another thing is that you want to have things like identifiers be resolved before macro expansion. This is another problem C has in addition to the previous one. I don't know why the animation is so whack there, but it's okay. And so in this example, we have this setX function. And so this basically says that we have some, x prime, some other x, and we want to update x as being equal to x prime, right? So we change the value of x here as a macro. But what happens? Well, this gets expanded to basically just be x equals xp, and it sets the local variable x, not the one higher up that we were expecting it to do. And the thing that's interesting about this is that the macro set x has no knowledge that this variable x even exists at all, right? And so this gets into some of the weird things where you have this scope problem going on, right? The best case scenario is that, x doesn't exist and the program fails because it can't find the variable, right? For instance, if int x wasn't defined here, it would actually just go to this one, right? So it would do the right thing if x weren't key, but if it were in a separate file, then it wouldn't do the right thing again because the global x would be somewhere else, right? So it depends on what things are accessible and in scope. Oh yeah, the diagram here. So this is basically the idea of hygienic macros, right? Instead of basically merging these scopes together and having the macro just jump into the scope that it was previously, you want to have a separate scope here in blue that the macro remains in even after it's inserted into the rest of the code there. And this is kind of the idea. Yeah.
So the thing about how the issue with scope, how is this different from if you declared set x as a normal function? And, for example, if you just declared set x as a normal function and you pass it in by value instead of pass it by reference.
Yeah.
Would you run into that same problem?
Nope, it would set the global x, right? Because if you had a normal function here, then in this function, x would refer to this one, right? So the thing that's weird about C macros here that you have to remember is that this x equals xp, right? This is not actually an assignment or anything like that, right? This is not like assigning a variable or doing anything like that. It's textual code, a string basically, that represents the idea of assigning to that. So the text from here is literally copy pasted into setX, right? That's pretty much how it works, right? And so it's a weird distinction and kind of a weird thing to kind of wrap your head around, but it might be worth kind of pulling up Define a little bit and playing with it, right? That's why this example here works, right? This is just basically saying, oh, if you see this, then that means int. So replace this with the text int, right? Like this is not normal code. right? If this was like a normal code in another language, the macro system would never be able to make head or tails out of it. The only reason it works in C is because it literally looks for whatever hashtag define is and just textually replaces it. Yeah.
So there's no jump to, it literally just places it. Because the function
No.
will jump to a certain place.
Yeah, no, like this function doesn't at runtime like at all. Right? There's no function being defined or anything here. It's just copy paste this down. In the case of C, in more modern languages that have proper macro systems, that's not the case. Like in this example. Okay, so checkpoint. Here are the kind of four main ideas. So language is more than just a compiler, right? We talked about some of the other things that were involved. You know, the design of the language, the different tooling that's involved, other things like the standard library, of course, community. And I don't want to forget that. So, yeah, we love you, fans. Woo. Okay, the compiler transforms source from one language to another, right? So we kind of went through the different steps, right? You have the lexer, then the parser, then the analyzer, and then like an interpreter or compiler. But fundamentally, the job is to basically bring in all that information, do some validation work, and turn it into another language at the end of the day, right? And that pretty much repeats until eventually you get into machine code, like maybe like 4 or 5 levels down the line. Right. Finally, type systems are a fundamental part. The interesting things to know about type systems are some of the things of how it's defined, kind of what a type represents, and how varying that they can be throughout different languages. So it's worth kind of keeping an eye on. And then finally, code is data, data is code. Right? This is kind of the fun, lispy saying of macros are awesome. Okay. So, actually, any further? Does anyone have any questions and anything to discuss here? Yeah.
Well, this is kind of like something that's a bit outside of what we talked here, but
Go for it.
but a bit recently, I decided to look up how like what language is the C++ compiler written in, and I think just the Google search result just told me it's written in C++.
Mm-hmm.
And then I did the same for Java, and then they said the Java compiler is written in Java. And this sort of boggles me a bit, because how can a compiler be written in the language that it is supposed to compile?
Yeah, so the Roblox compiler may or may not be written in Roblox. It's not, but that is the end goal. First off, I'm not sure if people on Zoom can hear the question, so to quickly repeat, I'll do that just in case. The main question is, if you have a language, how is the compiler for that language written in the same language? This is actually a very common idea in compilers. It's called bootstrapping. So the idea is you literally bootstrap your compiler with that one. And the standard way it's done is that you write a compiler, a very basic compiler in, say, C++. And then you can implement a compiler, you write code in your language, you use the compiler that you first wrote in C++ or whatever, have a version in your language that has now been compiled into something that can be run. And then you can use that version, the compiled version, to run whatever updates to the compiler you make. Now, it can get very tricky if, you want to add a bunch of new features, but you can't even begin to support those features because your language doesn't have the features needed to write the implementation for that. So it can be a trap. But once you get past kind of a certain critical threshold, then it becomes relatively trivial. And bootstrapping your compiler is generally a pretty good idea to do. Generally, one reason is it allows you to test everything in a relatively sophisticated project. That's a good reason why. The other reason is that in general, you're writing the language to be able to do better things with it, right? Like Rust, for instance, right? If you're writing Rust code to validate memory allocation and stuff like that, compiler seems like a pretty sophisticated thing where it would be good to have those types of features in. So that's another good reason too as well. Plus, just for design, even the mindset of kind of working with that language. So that's another cool reason. So yeah, anything else? Yeah, go ahead.
I think it might just be better for us to not be on like 7 questions.
Sure. Okay, so this is part infinity. effectively parts 1 through, part 0 is just kind of recap. Parts 1 to 4 are things to remember, and then everything after that is the stuff I want you to remember, because it's cool. I like robots. Anyways, okay, so what we're going to do is we're going to look at just testing everything to make it work. That to edit that too. I don't think. Well, it works, but I want to share something else too. But we'll see. Let's start with hello world in Roblox. I need to hide this little meeting bar because I can't see anything. I don't even know what that is. Okay. This is print. It looks about, well, I guess it's hello world really, but it looks about what you'd expect. Now there are some interesting things here, and I'll do a slight segue. What problems could a language run into that just wants to basically do print like this? Yeah. So there's no main function, right? So that could be a thing. So basically the idea is like we're just running raw code here, right? So that is something, not exactly what I'm looking for though. So not that it's wrong, I'm just looking specifically about the print function. Yeah.
There's only like one kind of print function, like C, you have print F and other ones.
So that's true. So it's a little less relevant here because in like printf you do templating. Robust has another method for string templating. So like in Java, right? How do you print something in Java? System.print line, right? So there's a few things buried in there. One, you have some system namespace, right? An out thing, right? It's a print stream, but it represents whatever standard out is. And then print line, which is printing a full line, which includes the new line at the end. So for instance, as written here, this doesn't have a way to say don't include a new line, right? You need to have a separate function like write, let's say, that doesn't include a new line. Or you could say this doesn't do a new line, just require them to put, new line characters at the end of everything like C, but that seems like a step backwards. You also don't have a namespace. So if I wanted to define my own function print anywhere in the system, it would start conflicting with this. And so there's a variety of weird, interesting things that get like that. Zig, for instance, doesn't have like print or anything like that, right? It has like standard things where basically like, if you want to print something, you have to import the specific type of thing related to what you're trying to print. For instance, not all applications are run via the command line, right? Some are just normal desktop applications. Where does that print to, right? Like if I'm running a desktop application like Slack and it just prints something, like where does that go to? I have no idea, probably nowhere, right? Maybe a log file or something, best guess. And so if you don't know where you're printing, that can be a weird thing too. So print is not something that you would use in every application. So sometimes it makes more sense to include something a little bit more specific. JavaScript, for instance, uses console.log. That's a pretty good idea, right? Because if it's in the browser, then you have console for all that type of stuff. And then you can do things like console.log, console.error. You can pass in objects and have it do sophisticated things like that. So some very powerful things it can do there. Yeah.
You're not sharing.
Oh, no. Okay, well, at least it's only hello world. I just hit the floating meeting words too. New share, interpreter. Cool. Nice. Okay, print hello world. This is not too much. Let me zoom in a little bit too, if I can. How do I zoom in? Control plus, maybe? Oh, well, let's see. File settings. I don't know why, but the two-finger zoom doesn't seem to be super good. So let's change this to, say, 16. There you go. A little bit better. So, and I need to hide this again. Nope, that's not it either. Okay, let's take a look at another example. So here we have FizzBuzz. This is kind of a standard program, but it does look a little bit weird. So let's kind of briefly unpack some of the things going on here. First one is this, right? So we have this range function. So 1, 15, right? So obviously these are bounds, right? So what is this :incl? Any ideas? Inclusive, right? So why would we want to have this here? Right, so it includes the 15. So what would this do? It's a trick question, it's an error. And the reason why is because it's very easy to look at this and not be totally sure, right? Pretty much every language has standard on the idea of inclusive lower bound, exclusive upper bound. So you can take notes for that one. But nonetheless, in general, it can be a good idea to include some of this type of things, because if you do want to change it, then at least you have an option to change that if you wanted to. Some reasons might be like sometimes you can do it like this and basically say these are the values, right? I want to run this 15 times basically. But you can also do things like this where you have 0 to 100, right? This makes sense. And this also makes sense. So depending on what you're trying to do, you may want to run this in different ways. I'm going to change this back to 15. That way we don't get 99 lines of output later. So actually this was 1, so we would have gotten 100 lines. See, I'm already making mistakes there. Okay, so next is this .4. Anyone have any idea what this does? Yeah, it's just a for loop. It's just fancy syntax. That way you don't have to put for everywhere. So you can do something and then just do .4 on it, and it'll run for every time in that collection. It's very much like for each. Then we have match. So match is this super cool thing. Pattern matching is a crazy topic, and I love to talk a lot about it. But right here, basically, we have a list, right? These are list literal braces, just like JavaScript. And basically, we're saying that we have mod 3 and mod 5, right? Oh, sorry. Val. Anyone have a guess what val is? Value. Basically, whatever variable or whatever value is being iterated over in this loop. Val is just the name of that parameter by default.
By default. So you can change it.
If you wanted to, sure, you could do something like for. Well, I mean, it's basically this. Right? Yeah.
Okay, I guess this is just kind of a robust question. Let's say, first off, does Roblox support objects?
Yeah, it's a standard object-oriented language for the most part.
Okay, so let's say if you have a function like this inside of a class member function, right? And one of the variables in the function is named val. It's very common with like a lot of node-based objects, like with a lot of those structures. If you had a val variable there, and you had this, which one is a precedence?
So in robots, val is a keyword, so it's a reserved word. So you wouldn't be able to have something named that in the same way you couldn't have something named if, right, or for instance. Which is part of the reason why the built-ins try to use reserved words here rather than anything else. So it doesn't conflict with other things. So yeah. So you could do that. So you would just have to assign specific parameter names to it if you wanted to be able to access both variables at the same time. But you would probably do something else than nested for loops to be better with what you're trying to describe with it. So yeah. So anyway, so to push through the rest of this example, basically the idea here is that if it's divisible by 15, then mod 3 and mod 5 is 0, right? So if it's 0 on both, then it's that. If it's 0 mod 3, but mod 5 is anything, then it's divisible by 3. So, and if it's the reverse, then it's divisible by 5. Be able to run this if I haven't broken it yet. Run. Let's see. So if I hit it, yeah. Woo! All right, we got like 3 more examples, so hopefully none of those ones break. Let's quick look. We're gonna do. It is very much like a switch statement, yes. The difference between a switch statement and match is primarily that in a switch statement, the cases never overlap. In a match statement, they can overlap, and it just depends on the particular pattern. For instance, these two overlap, but 0, 0 is higher up, and thus it takes priority, right? The other main difference is, of course, match has more crazy things like pattern matching and stuff, but you could do that and call it switch too. For instance, Java's switch is adding pattern matching. So it's just using the same thing, but it's using the same keyword. But an actual switch statement, like you're probably thinking of in like C++ or Java, is mainly designed to be able to jump to an arbitrary case directly. The other thing is that there's fall through involved, right, for many switch statements. Languages are also removing the fall through for that. Java, for instance, has a new version of switch that doesn't do false print. It can also return a value, so that's a thing as well. So yeah, switch that returns a value. It's super nice. Java is a pretty interesting language. Like, pay attention to some of the stuff going on. Java 18 was released yesterday. No, wait. Today's the 22nd. It was released today. So literally, Java 18 is, you know, like 7 hours old. Okay. Cool, cool. So we went through that example. Do we want to look at factorial or palindrome? I don't think we can see both. Palindrome? Okay. Palindrome is cool. It's for pattern matching. So here we have this palindrome. And so basically, this is just a list of anything. It doesn't matter. You could use a generic type, but there's no reason to. For the simple reason that there's no other type to compare this with. Yes. Any is basically objects. So give or take. Kotlin, like if you're interested, look at Kotlin and see how Kotlin handles the any type. Basically that. And so here, right, we use pattern matching on the list. And so when is something a palindrome? If it's empty, right, if it's an empty list, then it is a palindrome, trivially. So if it's a list with only one element, then it's trivially true, right? You could also write this as basically multiple patterns. I have it like this because I don't think I implemented multiple patterns yet. I might have now, but not at the time it was written, probably. Now, this is the last cool thing. So can someone try to explain what this line does? So mainly the piece I'm highlighting.
First and last node. It puts all the middle one to 0.
Right. So, and specifically because it's a star, right, this says 0 or more. So this matches something that has 2 elements, and it pulls out the first one and the last one, and then a list containing all the elements in the middle. You couldn't do like multiple stars, these sort of things. But even though this is at the end, it knows that there's a fixed length from the end, so it can figure that one out. And then this returns if first and last are equal to each other, right? This is just defined by however the objects implement equals. So it's fine. And then is palindrome middle. So this is designed for lists mainly because it was a little bit more fun for doing pattern matching, but you could do similar things with strings or whatever other type of stuff like your standard palindrome. So let's go ahead and run this one. Can I copy all of this in? Maybe I can. Let's see. True, true, true. What? 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 Okay. I don't know what happened to that last one there, but we'll run it by hand just to show that it hopefully works. That's right. No, it's not right. Oh, okay. So basically, IntelliJ's editor here had a panic attack with system_in because I pasted so much stuff in it. I hate when this happens, but basically you can see it didn't do this last line, and then it did both of them at the same time. That's what happened here. Also, you can see, right, the error handling here is super important, right? So in the REPL, characters 37 and 42, you can see these are just off. But this is where it's saying, right here, it's expecting stuff to, you know, basically stop because it successfully parsed a statement, but there's more stuff after this that it's not expecting, right? So this type of error handling is super cool and super useful. We can actually see an example of that here in a second, I think. Let's not paste the same thing again. There, okay, well, hit enter a couple times, you can see it runs that line and we get false for that, right? I'm actually surprised. Oh no, it did error, but it didn't crash the REPL somehow. Oh, I guess because it errored and then processed the remaining statements. Okay. REPL's buggy. Let's just say. Yeah. I mean, it's just very buggy. So yeah. Okay, cool. So that's palindrome. The very last thing we're going to look at is DSL stuff. And so this is an example of an HTML DSL. And so I think I actually want to write a little bit of this by hand to start. So what we can do is we can just have an HTML DSL. And this will just be a standard kind of H1 hello world. Hello world /H1. Right. And so you can see this is transformed into this structure. So we have an H1, and this contains no attributes, but it does have a child that contains a text literal of hello world, right? So this looks like a reasonable expectation of what, like, say, the DOM might be trying to store in here as a structure. So this can obviously just be turned into anything. It's just implemented to do this little, ASTS type transformation. But we can do some other interesting things with it. So for example, val name equals name, and then print hashtag HTML. So H1, hello, name, right? So we can just do this. And so this is called interpolation. So we can do that. And you can see we get hello name, right? So this is accurate, right? So we have everything we need there. And then what else do we want to do? We want to do, let's do an ID. Actually, we can just do this one inline. So let's say I had something like H1 ID equals, right, we'll do a literal, and let's say the value is 3. So this is ID number 3, right? We'll just use hello world again. So, yep. Okay, right, so you can see, so right here, this DSL has basically said that HTML attributes require the values to be type string. So in other words, it's saying that we have some attribute ID, we have a value that we're passing to it, and in this case, I used a constant, right? But I also could have used something like, a variable of type integer, and it would be the exact same. It's doing static type checking on the actual attribute value being passed to this, right? This is not something that like React is doing normally, right? This is a lot more powerful than that because these languages are able to communicate and basically say, these are the types of things I'm expecting. It is a relatively standard type of like JSON-esque protocol, right? So you can say like strings, objects with these keys and other stuff like that, if you need to build more complex things. But this type of static verification is really important when it comes to things like DSLs. And then finally, the last thing that I'll kind of show, I think I need to stop this and uncomment out some stuff in main. So here we go. Okay. We're going to get some crazy stuff printed out here because we're about to print out the entire abstract syntax tree in IR for this. But this will kind of be the last kind of thing to show off here. And so if we have, I'm going to do a curly brace to open up a new statement, and I'm going to say val ID is equal to ID, right? Okay. So what's the type of ID? String, right? Why is it a string? So basically, but a little bit more specific, the ID variable is a string because it's been assigned and initialized with a value that is of type string. So the variable copies the type of the value it's assigned to. Now, if I do something like this, let's just say HTML. We won't print it out or anything. I need to. H1 ID equals ID, right? So curly braces to refer out to that one. Could I do something fancy so it, figures out, hey, use the one of the same name or not? Yeah, sure, I didn't do that. So one thing at a time. Hello world. Right, okay. Now what happens if I print ID? Okay, so what should happen here? I feel like I'm in the what talk now, yeah. Okay, what should happen is it probably errors because I forgot to put a semicolon here, so let's fix that. Yeah, that's going to break everything, isn't it? Oh, great. Okay, we're going to...
Like, does the color of the text match with Roblox?
We're just gonna semicolon. Okay, print ID. Okay, we'll run this, and okay, it looks right. Now, so first we can see it's printed, right? The string is printed. That makes sense. But there's something else that's kind of going on here that we have to dig into a little bit to see. So first off, let's look at the ASD. So the AST is how this structure is represented when it's parsed. And so we can see here, we have, some declaration of a variable called ID. Its value is ID, exactly what we expect. But then we have something more complex here. We have a macro that contains a DSL that has an HTML source in it that contains a tag of, where is it? So is it to look down at the bottom? There it is, name H1. Okay. So it's auto-sorting the properties, but that's the idea here, right? And so we can see our attributes here. There's some interpolation where it goes, right? This goes from being HTML AST to Roblox AST, right? Because if we look up at this example, right, we have Roblox source code, then here's HTML source code, and then within these curly brackets, it's back to being Roblox source code, right? That's a very wild thing. This is not something that you see on a normal day. Okay. So then what happens? Well, we have this print section here, right? And so this prints basically ID, right? Exactly what you expect. Now let's look at the IR. So when it gets to the IR, what happens? We have our declaration. We can see this build up some stuff, variable data, other stuff. But then the HTML AST thing kind of falls away, right? We can see now we just have a method that we're invoking. And the method that we're invoking down here, right, is this method, which is the H1 function, right? And so this H1 function is what kind of creates basically something out of that AST, right? And then, yeah, so then we have some other stuff in here, literals, other stuff like that, yada, yada. Here's the attributes. It's a little harder because I'm bouncing around. Now, here's our print, right? So this is the function print, right? Makes sense? Here's the argument that we're passing, right? This is the variable being accessed, right? This is ID. Anyone notice something interesting about this variable? Yeah. So it's immutable. Okay, yeah, this is interesting, right? Remember, what was the type of ID that we established, right? What was the type of variable? String, right? But now what is it, right? Like if we scroll up here, right? Type string, right? Oh wait, here's the variable, right? This is the actual variable, right? This is the variable object used to represent this variable, right? Its type is string. But down here, after the DSL, the type is HTML identifier, right? All right, so looking at this, can someone want to put the final pieces together and explain what happened here? So, very close, yeah. It's not that it got converted per se, it's still a string value, right? The difference is that what happened is because it's used as an ID, right? System recognized, hey, this is an identifier. It's not just a random string, right? Like it's not going to be a string with like 12 spaces, and then like 8 hashtags and like a whole bunch of Unicode stuff you've never seen before in your life, right? It's going to be an identifier, right? It has to be a valid HTML identifier, which, I don't know the exact rules, but normally, alphanumeric, maybe an underscore hyphen, something like that. And so what it did is it said, you're accessing this variable. I'm going to update the type of this variable to specify that it's an identifier because it was used as an identifier. Now, if it's not an identifier, then this will error, right? And so it's responsible for making sure, like, if I'm going to assert that it's an identifier, I also have to validate that at runtime, right? But in the rest of the code, ID is going to be updated so that its type is an identifier. That way, it's always going to have that type, and so you can do kind of, other miscellaneous things with it, right?
Try to add an ID or try to concatenate ID with another string with just like issues.
That's a good question, and that just depends on how HTML identifier is. strictly speaking, in this case, how I'm envisioning it is it's still a string object. And so it's just basically HTML identifier is a thing that is a string and thus has much of the same stuff on it. But you could also do it like that. And of course, this is a bit of a contrived example. A slightly better example where it would be like you use a number, like you call square root of a variable. And so the variable that's called is a number. And because you called square root on it, you know that it couldn't have been negative. Because if it was negative, then that function would have thrown and other stuff like that. It's very similar to like C++ undefined behavior and other stuff like that. So it recognizes how things are used and adapts the type system to include that information for handling things later on. Because for instance, if you were to say, first take the square root of x, then if x is equal to -2, do something, well, that's dead code, right? X can never be equal to -2 at that point because it just can't happen. So this type of thing is called a refinement type system. So it's basically as you use the different values and variables in the program, the type information that corresponds with what it learns about using those is added in. And the job of validating that is mainly sent over to the runtime, but you don't have to like validate crazy things at compile time, right? So it's like, I'm not validating that the variable is positive at compile time, right? What's happening is that the function called is asserting that the variable is positive at runtime and erroring if it's not. That's kind of what's happening. Does that make sense?
Yeah, so what happens during run?
Yeah, so all the fancy stuff for validating it happens at runtime. But at compile time, it refines that information, and so you can find cases where things just don't make sense because you know how the values were used previously, right? It's very similar, like if you've used an IDE and like you've checked to see if a value is not null, and then you check to see if it's not null again, it won't like that. Or if you never check if something is null or whatever else, it'll check for those types of things. Same type of idea. Yeah. Kotlin does that, for instance, right? So like if IR equals null, right? Like you can see, IR null is always false. But if I did like val x equals, null, right? So if x equals null, right? Now it's actually verifying that it's true because it goes even a step further and looks at some of the actual constant values. But this is kind of the rough idea. Not a good example, but that's the idea. We're kind of at the end of it here. If anyone has any other questions, feel free to ask afterwards. But I think that's kind of a wrap on things. I guess I'll, pull out the slides. I know the people on Zoom can't see it, but there you go. If you have any questions, let me know. So, Sachin, and that'll be a wrap.
Yeah.
See you all
Next week
next
will be software testing.
Next week?
Next week is software testing.
Huh? Probably. So I'm probably gonna go bowling after this stuff.
Oh,
If you want to. Yeah, feel free.
First off, I noticed that it's challenging. You seem to be running this file called main.pt. What is that? With anything?
This is just the main method basically in Kotlin. That's all. It's just a standard name to basically say this is the file that has main in it.
I mean, like, what's its role, in like your language?
So this is the REPL specifically. So the REPL is read eval print loop. So its job is to basically allow people to type in robust code and then be able to execute that, and it will basically read it, it will evaluate it, which is parse, analyze, and eventually interpret, evaluate. It'll print the results of that. If I drop something in it. And then it'll just loop, right? It'll do that repeatedly. So you can do things like, you can define variables and do things like, let's say val x equals 10, right? It's printing out the AST and IR, so it looks a little messy. But you can do like print x, right? And it preserves that value for the duration of the REPL. So it's good for testing things quickly, trying things out, running simple scripts, any of that type of stuff. So most modern languages have some type of REPL available.
Okay. My next question is, can I see like what like object-oriented pattern you use?
In what regard?
Sorry, I mean, not just, you said, Roblox was object-oriented, I just want to see that, like how it, like how does that work?
Well, so for instance here, palindrome, right? So, well, example, that's yeah. So for instance, right, mod, right? This is a method on that object, right? So it's not like an operator. So which is part because the operator for mod is always confused between mod and remainder. So there's that aspect as well. But for instance, even in things like palindrome, right? This first equals, right? This is calling a method dot equals equals, right? So like if we look through, right? Actually we can't because it's specially implemented. But this is going to call dot equals, right, on first. So we'll call first dot equals last, right? So everything is designed around like trying to minimize all of this type of stuff. So it's purely object oriented in that regard, right? It's pretty much just methods for just about everything.
You like define your own type.
Yeah, I just don't have most of that implemented, mainly because I've been focused on statements.
Okay. And I guess my last question is, was this fun for you?
Yeah, I mean, it was a hell of a lot of fun. So I did my senior project on Robust. I did my honors thesis on parsing embedded DSLs, and then my current master's thesis is on semantic analysis for embedded DSLs. Writing it was a little bit less fun, but going through some of this and doing all of that, definitely interesting and a worthwhile thing to kind of do. My computer isn't strong enough to hold your camera, Eric. I didn't? You plugged it in. I mean, writing the paper. Yeah, writing the paper. You're going to see this thing? Look at this nonsense. Semantic, and now, yeah, there we go. Yeah, pick up where you left off. Yeah, I have some work to do. Yeah, this thing is 29 pages.
The thing is that, I mean, I like the idea of like writing my own language. It's just that the way you put it out there sounds horrifying. But
well, I mean, I elaborate on things. It's fun and more entertaining, right? It's just more entertaining involved in things. The short thing is that if you want to do a very reasonable language, you can do that in no time, right? So for instance, the original version of this presentation that I'd done a few years ago actually involved writing a compiler and interpreter for basically taking Racket code and turning it into Elixir code, right? As just a standard example. There was some, general standard library stuff and a little bit of framework things filled up around it, but it was like 20 minutes and that was it. But that's me kind of knowing what to do and building things where it was feasible to do in that time. But the point being is that the core things going on there are not super complicated. You can write a reasonable parser, you can write a reasonable interpreter, and do things like that pretty easily. Most of the hard stuff about this is all the semantic analysis stuff, right? Like I have a paper describing this, right? So is it this? These is this? Nope, not even that. 41 to 9, right? So analyze this. 32 lines, right? These 32 lines is like 10 pages of my paper, right? On what this thing does and what it enables, right? Because it gets complicated, right? This is the algorithm used for how it manages different contexts, and it can send contextual information like type information of variables to and from DSLs in a way where they can communicate with it effectively, right? And the thing about context and other stuff like that is like if you branch, right? Like if you have an if statement, the true part has one context and the else part has another context. And you have to like mix and match and combine them and do that very carefully. And there's not really many things that are very defining that, so I define it. Right. As far as whether it's fun or not, I enjoy it. So it's, baby steps through the language, but it's definitely interesting. So
The thing is, I haven't taken programming language concepts. I haven't even taken data structures yet. I'm very okay, and I feel like I'm very like low level in the.
So
computer science
I started
teaching.
working on scripting-esque type of stuff, which eventually led into full language before I started in UF. Right, I started in the spring because of Innovation Academy. So like I had an online class in the fall, but I started in like November, December. I basically like the earliest record that I have of Roblox stuff, I think is July 15th. Right, that's basically Roblox's birthday. I was in discrete at the time.
Yeah.
Right.
Yeah.
So that did not, this did not happen as a result of being in discrete. It happened over a variety of things. But I learned most of the stuff, through my own experimentation with things. It's find something you're interested in and use that as the motivation and justification to learn whatever else you need to.
I'm not saying that there's no way I could do this because I'm low level. That's not what I'm saying here. I'm just saying this isn't really something I've explored. It's not something I've been like totally interested to the point where I'm like, I want to do this right now. Like I don't like I'm not going to like wait till I get the PLC or anything. That's not what I'm saying here. But more, it's more about like this is something that I find and that I do find a bit interesting, and it is something that I feel like I kind of want to do. I just the way you
It's kind of like where to get started.
the way you put it, it makes it seem like you got to like commit a lot of time, like almost like your life to this. Can you?
Well, keep in mind, like I'm developing new research, right? I have fun with that. If you just want to build a language, right? So this is how I got started, crafting interpreters, right? This person, Bob Nystrom, is incredibly good. They actually work language, but they wrote this, and they also wrote game programming patterns, right? Which was also a textbook that I used in the game development workshops, right? These are incredible resources, and they walk through everything. This right here, this is the textbook for PLC, right? The assignments for PLC were written around crafting interpreters.
Literally this.
Half of it.
I didn't know there was a
Wow.
I mean, it's not well covered, but it is addressed and it's referenced multiple times in the assignments, right? This is basically like for interpreter section. It goes through lexing, it goes through parsing, it goes through the interpreter. It doesn't do a lot with semantic analysis because the language that they build is dynamic, right? That's the cop out. Most of the resources you find do not do much with semantic analysis beyond very trivial basics, and you have no idea how to generalize that task. So the stuff that I'm doing with semantic analysis is the much harder, less documented part. But you can still do a lot of very reasonable things with the relatively simple pieces.
Without spending 4 years on it.
Oh yeah, absolutely.
Okay.
So for instance, the current version of the language, is 7-8 months old. Right. I have other iterations that were made and scrapped and other stuff. I also